People, what's happening? It's your boy George Tutorials. Welcome to today's tutorial. So today we're going to look at scikit-learn, how to build and train our model using linear regression in scikit-learn. So without further ado, let's dive into my tutorial. Please don't forget to click that notification button for follow up, subscribe, for like, and also put your comment on the comment section box and let me know your mind. And if you are enjoying the tutorial, please help me to beat YouTube and Facebook algorithm to ensure people like you see this video and also gain value in it. So let's go to my computer desktop as we begin to code. Okay, I am in my Jupyter notebook. So what I want to do now is to import all my dependencies. The first thing we need to import, since we're using scikit-learn, not neural network, is to import our pandas as PD. Alright, so we also need to import our matplotlib for visualization, matplotlib.pyplot as PLT. We also need to import seaborn just in case. Seaborn, import seaborn as SNS. Alright, so seaborn matplotlib, okay, matplotlib.pyplot as PLT. Okay, let's do it again. Alright, I did not put import matplotlib.pyplot as PLT. Let's go ahead and run. Alright, so our code is working. Let's wait for it to load. Still loading until this turns to 1. Alright, so we have executed 12 times. Alright, so let's go ahead and import our data set. This is where my data set is. I want to use this California housing prediction. So I'm going to copy this path, okay, and come here and say, okay, I'm calling df equals to panda frame.read as a CSV file underscore CSV. So I'm going to paste my path, and I want to look at the head of it. Alright, and go ahead and run it. Okay, this is the data set we are going to work. Let's go ahead and rename our Jupyter notebook. Let's put it linear underscore regression. Alright, so regression. Let's rename it. Alright, so if we look at our data set, we have longitude, we have latitude, housing, median age, total rooms, total bedroom, population, housing, and also median income and median house value. And we need to do what we call data processing or data wrangling. I don't like this longitude that has this negative sign here, so I just want to drop this. There are many ways you can do. You can replace it, you can remove this minus sign, but I just want to go ahead and drop this to drop the longitude column as a whole. But before then, let's check if our data set has any null value. Alright, let's sum it. Okay, there is no null value. Let's go ahead and check if there's any duplicated. Let's go ahead and run it. Okay, false. There's no duplicate value. Alright, so let's go ahead and say sns.heat map. Let's look at the heat map of total rooms. Alright, okay, so let's paste it there and let's run this. Must pass to 2D input. df equals to, should this heat map missing one required positional argument. Okay, alright, so Stay with me. Alright, so data equals to df. Let's run this. Okay, let's just go ahead and look at df as a whole. Alright, so this is the heat map for the data frame as a whole. Alright, sorry for that little break. Alright, so what heat map does, that it checks the correlation between each of these values, okay? But that's not the focus of our tutorial for today. You can check Pandas documentation to learn more about that, or you can also put on the comment section, let me know what you want me to do for you. If you want me to explain, you can also put on the comment section. Alright, so let's go ahead now and drop this column. Let's say df.columns. Sorry, I've been a bit busy. So alright, so now let's look at df.columns. Alright, so you will see we have longitude, latitude, housing, the same thing we have here, but I want to drop this column of longitude because I don't want this minus sign. I don't want to remove to process it for today. I just want to show us how to use linear regression to make predictions on our continuous value. So to drop this, we say df dot drop columns, sorry about that, equals to, judge, what are you typing? We can just pick this and paste it here. And now if I go ahead and execute this, alright, and go ahead and execute this, it will not automatically remove this column from my my data frame. If I go ahead and say df.head, okay, I will still find this longitude rather still here. For me to permanently remove it, what I need to do, I need to come back here and say comma in place equals to true. It means it should affect our whole data set. If I execute this and I come back here and I execute this, you see that we have successfully dropped that column. Alright, so let's go ahead now and import our scikit-learn libraries from sklearn.model_selection import test_split test split train test split, sorry, is string _test _split. Alright, let's go ahead and run it. Okay, it's working. Alright, so but we need to import other dependency from sklearn, alright, dot linear _model import linear regression. Alright, so from sklearn dot metrics import mean _squared error r square score. Alright, let's run it. Alright, so we have been able to import our scikit-learn dependency. Here we imported pandas, matplotlib, and seaborn. Now what we did was to use this matplotlib or seaborn for our visualization, which you use SNS to get our heat map. You can also use matplotlib to visualize your data. For example, if I want to visualize I want to see count plot for, let's say, total bedrooms. So what I can do now, I can say, okay, I need to add here. All right, I can say plt dot, or I can say sns dot count plot. What am I say? Data equals to df, and we're going to look at, let's say, population. All right, so say population. If I go ahead and run it, so argument follows keyword argument. Count plot, let's say population, and run. All right, so this is the count plot for population. Now we have the count plot of population. So this is how you can use Seaborn for your visualization. So let's go ahead and do our scikit-learn dependencies. Okay, let's go ahead, and the first we need to do, we need to split our data set into X and Y. X has to do with every other dependencies, okay, every other dependencies excluding the target. All right, like I said, X train X as it had to do with every other variables except the target variable. Now the Y contains the targeted variable. Let's say, okay, X equals to df dot drop. We are going to drop every other except for the target group, target variable. Columns equals to want to drop what are we going to drop? What are we going to drop? What are we we are going to look at let's use okay, let's go ahead and drop population. All right, let's drop population. All right, so in our y-axis equals to df, we're going to bring back our population here. All right, let's go ahead and run it. Okay, we have been able to split our data set into train and split. All right, so let's go ahead and do train and test. Rather, let's go ahead and now do X train, capital X underscore train, Y underscore train, X underscore test, Y underscore test equals to, all right, equals to train underscore test underscore split, and we're looking at X and Y variable. All right, and the test underscore size equals to, let's use 30%, 30% for testing, and we are going to use random state. Okay, random underscore state equals to, let's say, 42. Now let's go ahead and run. All right, so now we need to call our model. So model or linear regression equals to, this is what we want. Copy it, come here. What is wrong with you, George? All right, so we have been able to call our model. Now let's go ahead and fit in our model. LR, that's model dot fit. We are going to fit our X underscore train and Y underscore train. All right, so let's go ahead and run this cell. X train is not defined. Why won't you be defined? This is okay, X train. Oh wow, please, you need to check your code to see if you have error. Okay, fit X train, Y train. What else? Found input variables with inconsistent numbers of samples. Okay, let's go ahead and check this. X train, Y train, X test, Y test, train, test split, X, Y test size. Okay. Linear regression, X the fit, X train and Y train. So all right, so let's go ahead and hit to fit our data set. You said lr.fit. Okay, I want to fit our X and Y. All right, Y should be small letter. All right, and go and hit. So if you see this, it means you have successfully your code is working. So we are able to import and call our function linear regression. So the next we need to do, we need to evaluate our data set. Now so okay, lr dot let's say dot score. Okay, what are we going to score our X underscore train, sorry, X underscore, okay, plus SMA equals to mean squared error. Okay, we're going to call, before then let's go ahead and predict y underscore pred equals to lr dot predict. Okay, predict our X underscore test. All right, so let's go ahead and run it. Convert it into numeric. What's happening? And let's go ahead and call our y underscore pred. Okay, this is our prediction. Now let's go ahead and look at the accuracy, the mean squared. Okay, we set y underscore test, comma, and y underscore pred. Okay, let's go ahead and call our MSE and let's run it. Let's just go ahead and call this. All right, so 19. So this is it. Okay, so let's go ahead and call our r square equals to r square underscore score, okay, y comma y underscore pred. Let's call our r2 and run it. At the square is at 0.85%. Okay, so let's do r dot score. Let's call our y and y underscore pred. Okay, let's go ahead and run this. What's happening? lr just score. Let's say y pred. Let's see, okay, X and Y underscore pred. All right, so our accuracy is at 100%. Now let me recap what we did in this tutorial. All right, so the first thing we did was to import our dependencies for our pandas, our data wrangling and visualization. We imported pandas as PD. We imported matplotlib.pyplot as PLT. We imported cborn as SNS. Now we use this our function df is equals to pandas pd.read.csv. It's a CSV folder rather file. So California underscore housing underscore train.csv is the file. We did this function df.head to look at the first 5 rows. By default, once you do df.head, it's going to give you five default rows of this. I went ahead and we did a count plot for population using SNS, that is cborn, and we had this. We also went ahead and checked our data. If there's any null value, we use the function df.isNull and .sum to sum it, and we had 0. There was no null values. And we also went ahead by looking at this function df.duplicated to show us if there is any duplicate value, and we found it as false. Now we can also get the sum of it. All right, so we go ahead and run it, and we have it as 0. So there is no duplicated value or cells in our data set. We also went ahead and looked at this function SNS, that is cborn.heatmap, to look at the heat map for this our data frame as a whole, and what we have is this. So what we are looking at, we can also go ahead and do something like correlation. We say df.core. Core means stand for correlation, okay? And we can also come here and use this and say df.core. all right, and we can also rerun this. It must pass through argument the shape df.shape data equals to df. Should this go? All right, so definitely we can still go ahead and stick to this. We can have this is a correlation between each of these items, each of these values in our data set, and this is the heat map for our data frame. All right, so we went ahead and looked at the columns of this. These are all the columns we have in our data frame. Now we looked at df.drop. We wanted to drop this longitude column. If you look at here, it has the data set has minus sign. So for this tutorial, I'm not going to walk you through how to change this. Okay, I just dropped the whole column because I will not be working with it. You can go ahead and drop more than one column. Just work with columns you are much interested in. It's not necessary that you work with all the columns. You can use 3 columns in the columns of let's say your data set may contain 10 columns. You can just work with 3. You can drop the rest and work with the 3 columns. So for me, I drop this longitude column, all right, using this function df.drop columns equals to longitude. And if you don't put in place true, it's not going to reflect in your entire data set, except you give it a new data frame, a new variable name. Okay, but for me, I still want to maintain this df data frame as a variable, so I had to make it to become in place true. That is, it must reflect in all my data frame. Okay, I went ahead and looked at to test if I still have it, but I didn't have it. Okay, so it was successfully dropped and only have latitude, no more longitude in my data frame. Now I went ahead and looked at my shape, the size of my columns and rows. So for this, I have 17,000 columns and rows rather, and 8 columns. All right, so here this is the main part of our tutorial, looking at how to use linear regression to create our model. I first of all imported linear sklen from sklen.model selection, import train test split. This function help us to do what? To train and test and also split our data. Now we also looked at the next library, sklen.linear model. This is the main model we are using for today, linear regression, so we have to import it. We also have from sklen.metrics import mean squared error and R2_score. All right, so this is to help us to evaluate our accuracy level. All right, this R2 score is to evaluate our accuracy score level. Now for you to be able to train your model in scikit-learn, you need to have it at the 2 x and y arrays, x and y position. All right, so for x, I have to drop all that columns. I have to drop this population. All right, so if I go to my x, for example, if I want to view my x now, it's okay, look at x dot head. All right, so You see, I have every other column, but no population. Population is not found here because I dropped the column population, because this is my targeted word variable. This is what I want to use to do or to make my prediction. Now for y-axis, I have to call back this population. So if I go ahead and look at my y variable, all right, you see that it's going to have only the population variable. All right, so for you to also be sure, if I go ahead here and say df, all right, and call my population function population, all right, population, all right, so you're going to have it. Okay, this is what we have by population. It's the same thing we are having here. All right, so we have the index 0, 10, 15.0, index 0, 10, 15.0. So this is our y axis. Okay, y value. Remember, we have x and y axis. So this is my y axis that is carrying this population only. All right, now we went ahead and for us, why the reason why we had to import this train test split is for us to be able to do what, to train our model and also have it as a train and testing site. Okay, we have to say x train, y train, x test, y test equals to train test split, and we are looking at x and y, and the test size is, I'm using 30% for my testing, random state 42. Now this is what random state does, is that at every point in time, if I should save this model and reuse it, it's going to give me the same accuracy level. Okay, it's not going to give me anything outside this. So this random state 42 is going to be giving me every time, it's going to give me accuracy of what my original data set or my training model was. Okay, now the next step is we need to call our function. I give the variable of LL, that's standing for, which means linear regression, and I had to call this function. Okay, and I looked at my x train shape. I had 11,900 okay color rows and 7 columns. My x train, my y train shape, I have 5,100. Now remember, let's do small mathematics, okay, for us to be sure that we are working on the same page. Now the total shape for this our data set is 17,000. Okay, where is it, okay, where is it, okay, so we are going to, okay, so let's just go ahead and check at our data frame. All right, so outside here we can go ahead and say, let's look at the, okay, let's say df dot shape. All right, if we run it, we are having 17,000 rows and 8 columns. All right, so let's go ahead now and say, okay, since what I want to show us is that we are using 30% of, okay, this is it, we are using 30% of our data set for training, for testing rather, and x train contains 70% and y train has 30%. Now if you say 17,000, all right, times 70 all over 100, we have 11,900. If you come here in our x train, we have 70%, we are using 70% of our data set for training. This is it. Now if you come and say, okay, come out, if you want to say, okay, you want to look at 17,000 times 30 all over 100, we have 5,100, which is giving us as this as our x train. So we are using 30% for testing and we're using 70% for training. Now after we've called our function, we had to fit in our x and y. Now say linear regression dot fit x and y, which we have this. Okay, if you don't have this in your own, it means your code is not working. Now we went ahead and did prediction. Say y pred on is equals to linear regression dot predict x, we call it, and this is a prediction it gave to us. These are the predictions. Okay, but you might not understand it now. Now I went ahead and did mean square error. Okay, mean square error y and y pred, we call it, and it gave us this. Now the r2 square underscore score is to give us the accuracy level of our data set. Okay, so R2, okay, is looking at the mean, median, the mean of our data, all right, of our prediction, which we have at 0.85 for. And now we need to look at the score of it. What are we scoring? We want to look at the accuracy level of our model. So we say linear regression dot score x and y pret. Okay, this is our y pret, the prediction x, which is this where we fit in as x and y. Okay, this is x and y. Now we have it at 100%. So ladies and gentlemen, this our model was able to predict and give us an accuracy of 100%. Okay, so it means our model is working very perfectly. Okay, now let's go ahead and save this model. How to save this model? Remember in our last previous tutorial, I showed us how we can save our model. All right, so we need to save this model so that we can reuse it. We need to first of all import what we call joblib. Joblib is a library for saving our model, and that's okay. Joblib.dom, that is the function. Okay, what are we going to do? First of all, call our model. That's the name of, okay, our model name is LR, and the name we want to, the variable name we want to give it as lr.model. All right, let's go ahead and run this. So we have successfully saved our model. If I come back here, you see that we have we should have our model saved in our folder. All right, look at it here, ll.model. So we have been able to successfully save our model. We did prediction and we also save our model. So we can also reload this model. New model equals to joblib, all right, dot load. What are we loading? This our model. Okay, since we are still having it in this our own. All right, so we go ahead and run it. We have been able to load it back. So let's go ahead and do prediction. New model equals to, all right, lr.predict, okay, our x, whatever x is. And if we go ahead and call this new underscore model, so it has been able to do what? To make predictions. You can also say lr.score, all right, score our whatever our y and our y underscore pret is, and let's go ahead and run this. Two-dimensional argument plus pandas, the score y pret. I'm coming. Okay. Okay. Sorry, x and y. So it's supposed to be x and our y pret. Let's see our accuracy. We see have it as 100%. This is what we have here. So if you are finding the value in this tutorial, please do well to like this video, comment, also share to your friends, your loved ones, people like you that wants to start a career in machine learning, and also let me know your mind on the comment section, what I'm not doing well and what I'm doing well. Please encourage me to keep doing more of this tutorial. Don't forget, my name is George. I'm a machine learning engineer using scikit-learn and also neural network TensorFlow. Please do well to hit that subscribe button if you're on YouTube, hit that follow up button if you're on Facebook, and share this video. See you in our next tutorial. I remain myself, George. Thank you. See you in our tutorial.